Do you hear me, please?
Yes, go on, please, Sam, go on. We can hear you.
Thank you. So as we know, I'm here today to present a case study of optimization using genetic algorithm of a nice crystallization for a new hybrid desalination process. As a sustainable alternative to solve water scarcity problem around the world. Actually, many technological advances and innovations are trying to improve the industrial seawater desalination process, essentially of desalinated water and reduce the environmental impact. Thus, development of a new sustainable process is among the most significant challenges. In our previous published works, an hybrid system, complete freezing and reverse osmosis, was proposed and developed. In the new proposed hybrid process, the freezing process is used as seawater pretreatment method upstream reverse osmosis membranes. Reverse osmosis is widely used to study the process. However, freeze crystallization method is never commercialized for desalination, and in literature we find just few studies in this field. Therefore, we have presented in previous work a modeling study of ice crystallization process from seawater. The developed model was based on population balance and energy balance equations. The simulation results show that the model is able to describe different physical and chemical phenomena of ice crystallization process from seawater, and also the main K parameters such as ice volume fraction and suspension temperature. We have also presented in previous work the application of the response surface methodology for the optimization of the freeze crystallization process using numerical simulation results. The obtained optimization results from the numerical response surface approach were satisfying. So the objective of this presented work today is the optimization of freeze crystallization process performance using genetic algorithms for multi-objective optimization in order to confirm the trends obtained with response surface analysis. For that, this presentation will be divided into three sections. First, multi-objective optimization genetic algorithm method. Second, formulation of the optimization problem. And finally, results and discussion. In last several years, numerous modification of methods based on genetic algorithms experienced a significant growth in popularity for solving multi-objective optimization problems. Based on literature review, it was emphasized that practically many of chemical engineering optimization problems were solved using multi-objective genetic algorithm. Genetic algorithm has proven itself as quite robust tool for multi-objective optimization and will, we expect, become even more popular in the future. It was inspired by natural selection. Genetic algorithm mimics biological evolution to generate better solutions from existing ones through natural selection, suited for class of optimization problems, and provide solutions for highly complex search space. So typically, genetic algorithm works through a cycle of the following steps. First, chromosome population, then evaluation of each chromosome to the optimal parity ranks and fitness sharing, then selection the best of chromosomes to do genetic manipulation that include crossover and mutation to create a new chromosome population. I go now to the second section concerning the formulation of our optimization problem. So in general, formulation of the optimization problem is divided into three stages. which are determining optimization parameters, determining the objective functions, and determining the algorithm control parameters. In our study, the multi-objective genetic algorithm is applied in order to determine the optimal design operation conditions for the new developed ice crystallization process within the scripted crystallizer. So the two optimization parameters considered based on the parametric sensitivity study are the temperature of crystallization process and the scripted rotation speed of the crystallizer. The freezing temperature is chosen in this work in the interval of -10 and -6 degrees Celsius, and the scripted rotation speed value is considered according to the factory setting that allowed the variation from 250 and 750 RPM. The formulation of optimization problem is aimed at simultaneously improving the productivity and the performance of the freezing pretreatment process. So the minimize the energy consumption. The optimization problem can be stated as the first objective function is maximize the ice volume fraction, and the second objective function is minimizing energy consumption. The mathematical formulation of objective functions is expressed in terms of moments based on the developed model published in previous works. The genetic algorithm for multi-objective optimization in our case was executed in MATLAB's Global Optimization Toolbox using an initial solution population of 200, a maximum number of generation of 100. A tournament selection method was used to select the best solutions for producing shy solutions. Probability of 0.9 was used for the crossover operator. The adaptative feasible mutation was selected to randomly modify the value of a gene in a chromosome. The Pareto population fraction of 0.7 was considered. All these algorithm control parameters were fixed after several pretests with different values selected from other optimization work in other fields in order to achieve the best trade-off between computational time and reliability of the Pareto optimal curve. As a result, the Pareto front obtained describing the best solution in the objective function space presented in this figure. It represents the best possible trade-off between the volume fraction of ice crystal produced and the energy consumption of the crystallizer. The shape of this front can offer general perspective about how changes in design variables would influence the study's process performance. So the optimal combination of conditions and predicted ice fraction and energy consumption are shown in this table. We can see that the optimal value of the freezing temperature and the script rotation speed equal to minus 9.98 degrees Celsius for freezing temperature and 457 RPM for rotation speed, script rotation speed. The common combination of optimum conditions for the crystallization process was evaluated over the fitness function. Simulation of this optimal configuration has made it possible to improve considerably the freeze seawater pretreatment process by increasing the ice volume fraction in the crystallizer exit with a value of 58.14%. And also minimization in energy consumption with a value of 5.959 kilowatt per meter cube. So in conclusion, in this work, the ice suspension crystallization in scripted surface heat exchanger process is investigated to develop an appropriate optimization design of the new freezing pretreatment process for seawater desalination. This was conducted using multi-objective genetic algorithm and the obtained results are satisfactory. They confirm the trends obtained with response surface analysis, the choice of the optimal design, operation condition, operation parameter in order to verify obtained results. Thank you for your attention.
Thank you, Mrs. Bjissam. I congratulate you for your presentation and for your respect of time. You are just in time. Thank you very much. I would like to ask audience if they have any remarks or question, please go ahead. Any question, any remarks? Please active your micro if you have any question. Okay, so thank you, Mrs. Bjissam, for your presentation. I would just like to have a little bit question. I would like to know where or which area you can use your algorithm. You can use all your results and experimentation. Which area can benefit from your research?
Sorry, I can't hear the question. If you can write it in the conversation.
Do you hear me now? Can you hear me, Mrs. Bjissam?
No, I can't hear well. If you can write the questions
yes, of course. Yes.
in the conversation, I can't hear well.
Okay. Mr. Tariq, can you hear me?
Yes, I hear you. And you? Can you hear me, please?
So I can Monsieur Tariq has a question. That's what is the novelty of my work. So the novelty of my work is the application of firstly the proposition of a new desalination process using or coupling freeze crystallization and reverse osmosis. The novelty of my work is the study of the freeze crystallization process from seawater. It's not applied in other fields. It's a new process, and there is no study in literature for this process. So we have developed a model for the crystallization of ice from seawater, and we have simulated our model and optimization the model to have the operation, the optimal operation condition. Methods to validate these results. First, the optimization of response surface method and optimization with the genetic algorithm, and we will do the experimental to validate these results obtained.
Professor Tariq,
Thank
if
you.
have other questions, or Professor Wesmi Nabila, do you have any question?
No, I don't have questions.
Okay.
I just can congratulate
Yes, please go
Ibtisam
ahead.
Bayat for her presentation, for her nice presentation.
Okay, thank you very much, dear colleague. So yeah, okay. So we go ahead to the next presentation, but we should congratulate Mrs. Ibtisam for her presentation. Thank you very much. So next presentation, it's for Mrs. Hayat Louafi with theoretical evaluation of ibuprofen and paracetamol.
Yes, I'm here.
Mrs. Hayat, yes, you are here, so please go ahead. You have about 15 minutes for your presentation, so you can share your video with us and we will follow you. Thank you very much. Go ahead.
Hello.
Yes, hello, please go ahead. We hear you.
I have the honor to present to you today part of a work entitled Theoretical Evaluation of Ibuprofen and Paracetamol by the Descriptors of ICOA and PAR, carried out in the Laboratory of Chemical Process and Applied Materials at the Faculty of Science and Techniques, Beni Mellal, under the direction of Professors Mohammed Al-Barghi and Mohammed Idrisi. The plan of work will be presented in the following way. After the introduction, we have cited the methods and the materials, followed by the results and the discussion, and finally, we will end with the conclusion. As you know, anti-inflammatory drugs are symptomatic drugs that do not act on the cause. Non-steroidal anti-inflammatory drugs are a broad class of drugs, comprising many molecules. They work by blocking the formation of prostaglandins, the substance responsible for inflammation. These products are often used in the pain of rheumatism, toothache, digestive trouble, and fever. Among the most commonly used anti-inflammatory drugs are ibuprofen and paracetamol, are aromatic compounds made for use as amity in the pharmaceutical industry, are non-steroidal pain relievers and anti-inflammatory drugs that thin the blood, treat headaches, and muscle pain. However, in the event of an overdose or drug interactions, ibuprofen and paracetamol pose serious problems for human health, in particular digestive tract, systemic disorders, endocrine disruption, allergic and skin manifestations. The determination of the stability of a molecule, we use the DFT method, which is based on the functional butyrolype, simulated by Gaussian software 09, which is software based on the fundamental laws of quantum mechanics. In this theoretical study, we used the following equations of the ionization potential and electronic affinity, absolute electronegativity, overall hardness, and softness. The LUMO and HOMO energies calculated for the two products. We provide a weak energy gap for paracetamol than for ibuprofen, which indicates paracetamol is more stable than ibuprofen. This geometric study also determined that the dipole moment of the paracetamol is greater than that of the ibuprofen. Hence, we can see that the paracetamol is polar than the ibuprofen. The electrostatic potential on the surface on the molecular are presented by different colors. The red parts indicate the regions of negative electrostatic potential. The blue represent the regions of positive electrostatic potential, and the parts of green colors represent the regions of zero potential. Also, the negative red regions of electrostatic potentials molecular are linked to electrophilic reactivity, and the positive blue to nucleophilic reactivity. Molecular population analysis is an important type of calculation. It's used to investigate the electronic charges on the atoms of the molecule. This figure presents the molecular charge of the atom. The most negative charge are the oxygen atom. This finding is due to electronegativity of the oxygen atoms. We calculated the charge densities of the atoms of the molecules, as well as the interatomic distances of these two molecules by the DFT Petrolite method. The value of these two quantities are gathered in the table. The optimized geometry of these two molecules show that the charge of the oxygen atoms and the nitrogen more negative compared to the other atoms. In this work, we use the most important factors that determine the applications of the molecular system as it is reactivity. The functions of acid key in a molecule can be defined in the following equations, where rho k n plus 1 and rho k less 1 is this natural populations of the atoms k in neutral, anionic, and the cationic species respectively. This table shows that Figui and the par indices, the F placed measures the density change when the molecules gain electron carbon 2 and carbon 5, and this corresponds to reactivity vis-a-vis the nucleophilic attack. On the other hand, F res corresponds to the reactivity compared to electrophilic attack, or when then the molecule lost electron is carbon 30. We have used the two functions of par plus and par less are obtained respectively by the analysis of the atomic spin density molecule of the electrophilic molecule and the nucleophilic molecule. And for paracetamol, the electrophilic sites are carbon 2 and the carbon 5. Elsewhere, nitrogen 13 and oxygen 11 are the sites sensitive to nucleophilic attacks. And 4, the function of power placed is the first carbon nucleophilic attack, and the powerless are the carbon 2 and carbon 5 electrophilic attack. Finally, the DFT method better of the electron density of certain atoms of the molecules allows theoretical calculation, chemical descriptors of calculation spin density, and molecular charges. The reactivity regions in a molecule can be analyzed using FORMULATION indices. This represents the regions in a molecule susceptible to electrophilic and nucleophilic attack. FORMULATION and the power function can be evaluated using molecular population analysis of atoms in a molecule. And thank you for your attention.
Mrs. Hayat El-Wafi, thank you very much for your presentation and also for respecting time. Yeah, I congratulate you. Thank you very much. So I give the floor to the audience if they have any question. Professors, my colleagues in sharing this session. Professor Wasmi or Professor Tariq? Wafi, if you have any question, please.
Yes, I have a question, Professor. Professor Wasni.
Please go ahead,
it's not,
Professor Wasmi.
It's not a question. It's just a critique from the presentation. First of all, I want to congratulate Mrs. Hayat El-Wafi for her presentation, and I want to know if, from your study, who is the inflammatory most efficacious from this study, paracetamol or ibuprofen? Do you hear me, Mrs. Hayat?
Yes.
From your study, you are talking about the density and the density of these two inflammatories. So, from your study, can you conclude some conclusion to say who is the inflammatory most efficacious for human to use ibuprofen or paracetamol? As you know that the most of people use these two inflammatories.
Yes, anti-inflammatories drugs are a broad class of drugs compares many molecules.
Okay. Yes, I hear you.
Yes.
I don't hear your answer.
Anti-inflammatory is a broad class of drugs.
Okay. Yes.
It's blocking the formation of prostaglandins, responsible for inflammation.
Yes, exactly. Yes. Yes, thank you. Thank you, Ms. Hayat.
You're welcome.
Thank you, Professor. Thank you, Mrs. Hayat. I think Professor Tariq El-Wafi has a question. He marks it in the conversation rubric. So his question is about why did do this theoretical study? Please, Mrs. Yes.
Yes,
go ahead.
Thank you for your question. My work, the novelty, is to study the chemical reactivity of our molecule by theoretical method and to predict the results that we can obtain experimentally. So here we are talking about 7 time cost.
Mrs. Hayat, do you hear me?
Yes,
Okay.
I hear. Yes, I hear.
Okay, we have another question from Mr. Mustafa. He asks you, do the indices of FOQ and PAR provide the same results?
Thank you for your question. The description given by the FOQ and PAR indices is used to characterize the chemical behavior of different topological regions acid molecule. And the FOQ index and the index of PAR give you information on the most electrophilic sites of the molecules. I tended for nucleophilic attack will F less and P less tell you about the most nucleophilic sites.
Okay, thank you for your answers. I think Professor Tariq Al-Wafi has another question. Is about, I would like to know information about the stability between these two drugs.
Yes, really, we have already studied the stability in previous work. We found that their energy LIOMO and OMO calculated for both we provide a weak energy gate for paracetamol than for ibuprofen, which indicates that the paracetamol is more stable than ibuprofen.
Okay. Is anyone has another question? Okay, thank you, Professor. Thank you. If there is no more question, I would like to thank Mrs. Hayatoshi for her presentation and for her interactivity. So thank you very much. We switch to the third presentation, please. Mr. Ayman Al-Warsh, please go ahead.
Yes, I'm here.
Yes, yeah, okay. You have about 15 minutes to show us the results of your works. Please go ahead. Thank you.
Okay. Hi, my name is Ayman Laush. I am PhD student in the University Sultan Moulay Slimane in the Faculty of Science and Technology. Before I started this presentation, I would like to thank all the members of the committee for their presence, for attentive reading of my work, and for the remarks that they will address to me during this presentation in order to improve my work. I would like also to express my gratitude to the directors of my thesis, the Professor Mohammed Mbaki and the Professor Mustafa Bouatiya, that I am submitting for the consideration of the jury today entitled Coupling-Mide Infrared Spectroscopy to Mathematical and Statistical Tools for Automatic Classification, Qualification, and Quantification of Argan Oil Adulteration. First, I will try to see the purpose of this work, and then I will explain the method by which this work was performed. Next, I will discuss the results obtained in this study. As you know, argan oil, due to its high price compared to other edible oil, can be the object of fraudulent practices of varying degrees of sophistication. The most common ones consist in falsifying argan oil with lower priced oil. This practice has been the subject of numerous studies aiming to combating fraud that disrupt the market and damage the positive image of argan oil. This technique, like high performance like liquid chromatography, gas chromatography, addictively coupled with plasma optical emission spectroscopy, are time-consuming, costly, and require operator skill and have a high environmental impact. So, vibrational spectroscopy combined with chemometrics tools or multivariate data analysis have been applied in argan oil adulterated with a commercial oil in order to develop methods able to quantify argan oil adulteration rapidly. To achieve this work, argan oil samples have been prepared and adulterated using a commercial oil. These samples are analyzed by mild infrared spectroscopy. The adulteration sample using for learning were treated from 1.3% until 15.7%, respectively. Our levels of adulteration investigated were calculated by the following equation. So the percentage of adulteration was the mass of adulterate in the sample divided by the total mass of sample. The adulterated and non-adulterated argan oil are analyzed by infrared spectroscopy, which is a fast, non-destructive method. The signal obtained by mild infrared spectroscopy show intense bands. These bands give information on the functional groups characterize argan oil compounds. Next, this information obtained by the signal coupled with regression algorithm for the development of mathematical models. So what is partially least square regression? Partially least square regression or PLS regression is a fast, efficient, and optimal method for a well-controlled covariance minimization criterion. It is recommended when a large number of explanatory variables are used or when there are strong collinearity between the variables. This procedure consists of performing a decomposition often on the Nepal's algorithm, non-linear iterative partially least square, of both the X and Y matrices under the constraint that the latent variable T extracted from X as correlated as possible with the factor coordinate or the latent variable extracted from Y, as presented in the figure. Support vector machine. Support vector machine can also be used as a regression method, maintaining all the main features that characterize the algorithm, maximal margin. The support vector machine regression uses the same principle as the support vector machine of classification, with only a few minor differences. First of all, because output is a real number, it becomes very difficult to predict the information at hand, which has infinite possibility in the case of regression. A margin of tolerance is set in approximation to the support vector machine, which would have already requested from the problem. But besides this fact, there is also a more complicated region. The algorithm is more complicated, therefore, to be taken in consideration. However, the main idea is always the same: to minimize error, individualizing the upper plan, which maximizes the margin. So PLS regression and support vector machine regression calibration models were performed on 25 adulterated samples ranging from 1.3% to 15.7% to determine the relationship between predictor variables, which is the absorbance and the physicochemical characteristic of argan oil. More precisely, to construct chemometrics model able to predict and quantify the adulteration of argan oil by commercial vegetable oil. The PLS and SVM regression models were performed on a spectral region of mild infrared spectroscopy. So according to the results of PLS, we observe that there is a strong relationship between the actual and predicted values. This relationship is explained by the R square, which reached 99%, and the root mean square error of calibration and cross validation, who are respectively 1.2 and 3.7. The SVM show also, or the SVM regression show also that there is a high correlation between predict value and reference value, in which we can observe a high value of R squared for calibration and cruise validation, which are 98% and 92%, and the root mean square error of calibration 3.5, and the root mean square error of cruise validation 7.6. These results are considered to be very performant, and the comparison of statistical parameters of the two regression methods show that the PLS regression presents a good performance for the prediction of adulteration. To conclude, the application of PLS and SVM regression methods have been shown a very high capacity in quantifying the percentage of argan oil adulteration by commercial vegetable oil, which is expressed by the high value of the correlation coefficient and the low value of the prediction error using cruise validation. The capability of the proposed method to quantify low adulteration has been successfully demonstrated. Thank you for your attention.
Mr. Ayman El-Warsh, thank you very much for your respecting time. I congratulate you. I would like to pass the floor to the audience. If they have any question, please go ahead. Dear colleagues.
Yes, Professor, I have a question.
Yes, please go ahead, Professor Wasmi Nabila.
I want first of all to thank Mr. Ayman for his rich presentation. It was very clear. And I want to ask what is the utility of your work in our society? I mean, in which domain we can use this research? As you know that Morocco is famous by production of argan oil.
So, thank you for your questions. So, this technique is from the process analytical technology. For example, if you want to determine the adulteration of, for example, if for argan oil or another edible oil, or for example, for pharmaceutical products, we need to apply, for example, the most common technique is chromatography. And how we know the chromatography take many time and require the use of many regions and take many time to, for example, to analyze one sample. For this reason, we try to develop a rapid method. For example, the use of spectroscopic method don't require the use of region. Just we collect the data and we couple it with algorithms, and this algorithm make us to determine very fast the percentage of adulteration in argan oil.
Okay, yes, thank you.
And we can also use it, for example, in the industry of pharmaceutical products to determine the percentage of principal active, or, for example, in agri-food product to predict the percentage, for example, of compounds that we need to determine.
So your method is valuable of on another products, not justly argan oil.
Not justly argan oil, but we can apply in other products.
Okay, yes, thank you.
Thank you very much.
Thank you, Professor. Thank you, Mr. Ayman, for your clarification and interactivity. If anyone has another question, yes, Professor Tariq has a question. Have you compared your theoretical results with experimental results? Please, Mr. Ayman, can you answer?
So in this moment, there is no reference method to quantify the adulteration or in argan oil. Just we are prepared the percentage of adulteration. This is our reference, and from this we can compare. We predict, and we use a new sample, and we predict the percentage of adulteration, and we compare the difference between the reference value and the value predicted by this model.
Okay, thank you, Mr. Raymond, and good luck for the next work, future work. If we don't have any question, let me please go to the last presentation. Yes, I think last presentation with Mrs. Nadia Raisi about viability analysis for a stock capital fishery model. Mrs. Nadia, are you here? Yes. Can you start? Mrs. Nadia, can you hear me?
Well, hello. Well, I will be presenting instead of Professor Nadia Raisi.
Your name, please?
Yes, my name is Uthman Sharqawi.
And Sharqawi. Okay. Very nice.
I
Yes,
would like
if you are ready, you can start. You have about 15 minutes to present the most important point about your work. Please go ahead.
Okay, thank you. So first, I would like to thank the organizing committee for this chance to present our work. It's a viability analysis of a stock capital fishery model. The two words you can see interested in this is a viability analysis and a stock capital fishery model. So it will be good to show you the framework of modeling the stock capital model and introducing the viability theory and showing you the important results we can find. So as an introduction, I will show you a figure of fishery in Morocco. And you can see that 6% of the active population works on the fishing activities, 1.5 million tons of total production and 3% of the GDP. Also, more than 60 species and 3,500 kilometers offshore. That means this is one of the most income activities to the Moroccan government, meaning its sustainability for the longest time will be the most needed at this time. So, the modeling framework, you can see that it's stock and capital model. So there is a biological part of the fishing resource, which is modeled by the logistic function, the normal logistic function, Rx multiplied by 1 minus x divided by L, where R is the intrinsic growth rate and L is the carrying capacity of the system. While the fishing activity is a production function. It's the usual production function, is a multiplication between the fishing resource and a new variable called the effort of fishing. So E is a fishing effort, and Q is known to be a catchability coefficient in the literature. And furthermore, I will explain it. So now we have two variables. It's an X and E subject to some constraints. One is a biological constraint, meaning there is the stock level should always be superior than an X minimum and should always be inferior than their carrying capacity, while the fishing effort should be always positive or equal to 0, meaning no fishing activity going on that time, or the maximum fishing activity, meaning we fish with the whole capital we have. So you can see that E, the fishing effort, is bounded by the whole capital, and the capital, if you cannot see it as a money worth, you can see it as the number of standardized vessels available for the fishing activity. So in the neoclassic models, economic models, you can see that the capital always evolve positively with investment and depreciate due to inflation. So it's modeled by E minus gamma K. So this one is a new thing. So because here you can see that E is between 0 and K. So all we do is normalize by dividing everything by K. And we have a new variable, which is alpha, which is equal to E divided by K, which is between 0 and 1. So this is just to substitute E by K or K by E. So what happened in the literature? So in 1979, Professor Colleen Clark, which is the first C, Gordon Munro, which is the M, and Francis Clark, which is the second C, has given us this work of art in 1979 that saved many fishing stocks in Canada. Its main objective was to maximize the profit of the efficient activity, which is the first function, maximizing G, which is meaning the net profit, while having a close by modeling likewise. It's a variation of the stock and a variation of capital. The difference is that they seems to take as control variables E, which is the investment. However, the investment in their case is a non-bounded variable, which means that E equal to infinity is allowed, which give us instantaneous jump at the capital level. So giving you the explanation of this work at this figure, so you can see that given us three policies, to maximize this function, to maximize the profit, given the controlled model, they're giving us three policies. The R1 region, meaning there is no activity, which is known now as the biological rest time. The second region, which is meaning the maximizing the efficient activity. And the third region is maximizing the investment, meaning that there is a lot of stock available, which means maximizing the activity to get more money. So we thought that since the CCR model has what's called maximizing the profit, what's happened if we don't maximize the profit? And our whole goal is to sustain the activity. So we extracted the dynamic from the CCM, which is controlled only by the investment, which might be unbounded. And we said that we will use two variables this time, an alpha to switch E to K, and also E, which was a control in the CCM model, and said that our goal will be just to sustain this model. We will not force ourselves to maximize the profit. Our goal is to sustain this activity as long as it could sustain. Given though our control will be constrained to these constraints, alpha should be equal to between 0 and 1. And E, which is the investment this time, is 0 infinity. Going back to the CCM model, you can see that E here at the CCM model was equal to infinity. However, in our model, we say that investment equal to infinity is impossible, so it should be bounded by an E maximum value. So there is this creates a new set of constraints on control, which is it is a rectangle, 0, 1 times E minimum, E maximum. So the sustain of the activity do not only depend on the fish population, but also the capital. So X should be always bigger than X minimum. And finding X minimum, it's the minimum value capable of rebuilding the stock if somehow we reach it. And L is the current capacity, and capital should be always K minimum, somehow equal to 0 if you want. So, or K maximum, which is the maximum capital available at the efficient activity. So dealing with this system of not having to maximize a function, but always to sustain a control system in a state of constraints, we found that there is a conceptual framework, which is the viability theory. It consists of studying the existence of control that verify or make the state stay at a domain named the viability constraints. So the viability theory, I will explain it in this simple figure, knowing that we have two states, X1 and X2, which is a dynamical system. We'll try to sustain this system in that domain named K, which is in the light blue color. So for any initial state, which is any initial value X1, X2, any control we can take in the light blue region, you can see that it exits the set, meaning that for any policy we will make, we will lose this set. For biological purposes, if you can see that if the stock level is one of these if we leave the set to the left-hand side, we will go to 0, meaning the extension of one species, which is bad. So we will try to stay at that set. So there is what's called the viability kernel, which is the darker blue side, which is that for all initial states in that set, there exists some control policies that force us to always stay inside. Not all of them, of course, some will leave, but it exists at least one that will make us stay. So this is just to explain the theory. But the theoretical hand side, we will need to move on to the multifunction values and create a multifunction system, control system, and do some analysis about it. So if we take that X dot is a multifunction, of controlled model, the existence of such a viability kernel, meaning the existence of a set which we can find some control making us stay at that set, need that the multifunction should be continuous with respect to the control variable, should also be convex for the control variable, the set of constraints on the control should be convex, and the multifunction should have a linear growth, which is practically easy to check out. So then we can state that the viability kernel is the set of all initial states for which exists a policy, control policy, for which the solution of our dynamical system will always stay in that set, which is H, the constraint on state. So we will try to verify if it's available for our system. So we create our multifunction with our dynamical system. It is clear to see that it verifies the assumption, these assumptions we made, H0, the hypothesis we make. It is easy to see that it verifies them all. So we can see that there exists a viability kernel, but in the theoretical hand side, there is some sort of ambiguous thing about the existence in the non-emptiness. So it might exist but stay at empty. So to show the non-emptiness, this value, which means we will show that there exists at least one stable equilibrium point for that model. And knowing that the equilibrium is viable if it satisfies the viability constraints. So this is one of the inside equilibrium we can choose. And if it's viable, if it's inside that set of constraints on the state, meaning that the second variable, which depend on the K star, should be between K minimum and K max. Also, the first variable, which is biological variable, should always be superior than X minimum in L. This will give us some new bound to the control variable, because you see that there's control on these two in this equilibrium. So it gives us new values for the minimum and maximum bounds for the investment, which is the control we choose. So now we have a new set of constraints on the control for which there exists a stable equilibrium point, meaning there exists of a viable equilibrium point and the existence of the viability kernel. So now we will try to, for this model, create that viability kernel. So it's exactly as it looks. Instead of going forward in time, we'll go backward in time. Taking this, we go at the time we will exit this set and run it back on time. For this, we will need to draw the inverse system, which you can see that our system was F minus, now we are minus F plus. So it's like going back in time, and our initial condition are on the bound. Like if we go forward by time, when we are at X minimum, we will exit the set. So we are on the bound and now drawing our way inside of the set. So you can find it here that this is the way we draw the curve. So C is the curve limiting the kernel, the viability kernel, and it's a solution of a dynamical system. And the curve C is characterizing the viability kernel, for which correspond the level of stock and capital for which we can define some controls that will guarantee the sustainability of the resource and always a chance to rebuild the stock whenever we feel weak. So for some following parameters, R equal to 0.5, L equal to 10, and gamma and Q equal to 0.1, we can build this following viability kernel. So the whole set is the intersection between the two bounds. So you can see it. And at the point 2 and 4 is the point where we will exit the set. If we continue on time, what we do is we run time back to step from where we came. And this is the darker blue color. It's the viability kernel, meaning that for every point on this blue set, we can find a control policy making us sustain the efficient activity for as long as eternity. So as long as we can fish, we will always have this activity. And that's for the conclusion. So the model is more restrictive hypothesis, since the viability theory is a quite restrictive theory. So it has more requirements than it needs. And we intend to return to this model and to distinguish between two normal components of the capital, the material capital and the human capital, for its interest that 6% of the Moroccan population work on this activity. And thank you, that's all.
Thank you very much, dear participants. Thank you for your clear presentation, respecting time and interesting thematics of work. I give the floor to our dear audience. If they have any question, please, dear colleagues.
Yes, I have a question.
Yes, please, Professor. Go ahead.
Thank you. First of all, thank you, Mr. Uthman Sharqawi, about for your nice speech and your clear presentation. I want to just know why do you choose exactly to analyze stock capital fishery?
So the stock up, well, in the literature, if I go back, you can see here that's going back to 2000 to 10 and 20 to decades, that the two components is a biological part and economical part. So what if we try to save the fishing activity while keeping the economy running? So we just try to take out the maximizing the profit, meaning that we're not thinking about maximizing the profit, but just getting them enough benefit to run the activity. So that's what our point was, to have a biological part, meaning the species will always be there, and an economical part, which means the capital, which means the activity will always be running smoothly.
Yes, thank you. Yes, thank you.
Thank you.
Professor Tariq Rafi has also a question. I would like to know the novelty and the applicability of your work.
Well, the novelty is that there is no study so far about the non-maximization of profit. So the fishing models, there's always the maximization of the profit. No one's care about the sustaining the activity, they care about the short-time benefit. So our novelty is the long-term quickly benefit, because the activity will sustain 6% of the population working. So you don't need to tell them to change work, because they will have their activity for as long as they could. The applicability for this work is just, it's applicable in Morocco. However, we tend to think it's less realistic, since the two components are not available yet. The two components mean the component of capital, human capital, and materialistic capital. However, if this model can run smoothly on numbers from the Moroccan government, it will run perfectly.
Okay. Thank you, Mr. Atman, for your interactivity. If there is no question from our audience, I would like, thank you very much. I would like to achieve this session. Thank you very much for all of you for your participation, attention, and interesting presentations. One more thing, please. I would like to welcome you in the closing ceremony, which will begin at 4:30, just about 30 minutes from now. It will be a closing ceremony to declare the best paper, and to show you some recommendation and some best moments of the international conference. So please, we will wait for you at 16:30 or 4 p.m. 30 in the closing ceremony session. Thank you very much. Thank you very much.
أمانة والله شقلها ليا اقسم بالله قال لي قول ماما واخا هذاك انونسي لا ميزاجور انونسي لا ميزاجور حيت خصني ندير بلان تخوك ماما هذاك انونسي ماما جو في لونسي لا ميزاجور Mais je vais lancer la mise à jour. Hier, elle dit que ça va durer 30 minutes, s'il te plaît. Avec. Maman, s'il te plaît. Oula, je vais juste lancer la mise à jour. S'il te plaît. Maman. Maman. Maman, avec. Maman. Maman, s'il te plaît. J'étais comme ça, lâche. Maman, maman, s'il te plaît. S'il te plaît. Maman. Mais maman, avec elle a été alliée, on va dire lancer la mise à jour. Avec. Maman. 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 Avec. Maman. Maman. Maman, avec. J'ai oublié, s'il te plaît. J'ai oublié pour les digérations. Maman. Avec, est-ce que derrière, Baba.